Hi, welcome to the podcast on Leonardo's Theorem, the third podcast. Um, Let me remind you that last time we classified all isometries as either, remember, even or odd. Even we knew already are translations, rotations, and odd ones are either reflections or last time we finished classification of odd isometries. And listed that only other possibility other than a single reflection as glide reflections. So this is our complete classifications of all isometries, translations, rotations. All right. So today we will look. Before we go on with today's material, let's pose an interesting problem that you are invited to solve on your own. So let's assume that 2 points are given. So here is a problem for you to solve. Given P and Q, given 2 distinct points P not equal to Q, list all possible isometries that take P into Q. So hint is that the number is smaller than you expect. You won't have 4 different types, but actually only 2. So given P is not equal to Q, list, describe all possible isometries taken P to Q. So at this point you should stop the recording, pause the podcast, and try and describe all possible isometries taken P to Q. Alright, so should take no more than 15 minutes or so. Hopefully you've done it and come back now. Let's talk about Leonardo's theorem. So Leonardo's theorem states in our terms that if you deal with any group of isometries that are symmetries of some figure, so if you deal with any finite group of symmetries, then actually we know what it is. We can describe it. More precisely, we talked about dihedral group and a cyclic group of rotations before. So dihedral groups Dn were the group of symmetries of what? Remember? Group of symmetries of regular polygons. So Dn is a group of symmetries of regular n polygon, and Cn actually we could present a polygon with 2n vertices, so-called ratchet polygon. That Cn was the group of symmetries of ratchet polygon with 2n vertices. So Leonardo's theorem, stated precisely, tells us that in fact any finite group of symmetries of any set in the plane is going to be either one of those, either one of dihedral groups or one of cyclic group of rotations. So, theorem attributed to Leonardo. Who was interested in the symmetries of buildings for architectural reasons, states that any finite group of symmetries of plane sets is one of Dm or Cn. So the proof will take us most of today's class, most of today's podcast, and we'll start with the case when our group of symmetries contains only even symmetries. So there are, of course, two kinds of symmetries we can rule out right away. What are they? Definitely, our group of symmetries cannot contain any translations. Why not? Correct, because a translation would generate an infinite cyclic group, and our group must be finite, so it cannot contain any infinite groups. So, out of 4 possibilities, translations, and what else? Right, glide reflections are ruled out right away. We are left with reflections and rotations. Reflections.